Preparing for a SRE at Datadog interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define and use SLIs, SLOs, and SLAs for a production service? An SLI measures user visible behavior, such as successful request rate or latency. An SLO sets the desired target, while an SLA is a contractual commitment with consequences. I would choose a few meaningful SLIs, define an availability and latency objective, then calculate the error budget. If burn rate rises, I would slow risky releases and prioritize reliability work. This keeps reliability measurable without demanding impossible perfection or wasting capacity on low-impact metrics. While answering, distinguish SLIs, SLOs, and SLAs. Explain user-centered measurements, error budgets, burn rates, alert thresholds, and how reliability targets influence deployment and feature decisions. Question 2. How would you investigate a sudden increase in API latency? I would first confirm the latency increase using P50, P95, and P99 metrics, separating affected endpoints, regions, and clients. Next, I would check traces to locate the slow span, then compare deployments, traffic, database performance, cache behavior, and host saturation. I would mitigate quickly through rollback, traffic shifting, or capacity changes if users are impacted. After stabilization, I would reproduce the condition, identify the root cause, and document prevention. Make sure to cover symptom confirmation, time correlation, percentile analysis, dashboards, distributed traces, dependency checks, recent changes, resource saturation, traffic patterns, and mitigation before root cause analysis. Question 3. What makes an alert actionable, and how would you reduce alert fatigue? An actionable alert indicates a meaningful problem, has a clear owner, and suggests an immediate response. I prefer alerts tied to user impact or rapid slow error budget burn rather than every low-level metric fluctuation. I would add severity, context, runbook links, and deduplication, then review alerts after incidents. Non-urgent trends belong in dashboards or tickets. I would measure success through alert volume, acknowledgement time, false positive rate, and incidents detected. In your answer, discuss user impact, slow-based thresholds, severity, ownership, runbooks, deduplication, suppression, escalation, testing, and measuring alert quality through noise and response metrics. Question 4. How do metrics, logs, and traces work together during incident investigation? Metrics tell me that a problem exists and reveal its scope, logs provide detailed event context, and traces show how a request moves across services. I typically start with a metric anomaly, narrow the affected service and time window, inspect traces for slow or failing spans, and use trace or request identifiers to find relevant logs. Correlating all three reduces guesswork, while careful retention and cardinality controls keep observability affordable. Be sure to mention the 3 observability signals, correlation identifiers, aggregation versus detail, high cardinality considerations, trace context propagation, and a practical workflow from detection to diagnosis. Question 5. How would you design monitoring for a highly distributed microservices platform? I would standardize instrumentation around latency, traffic, errors, and saturation, while adding business-level SLIs where appropriate. Every service should emit metrics, structured logs, and traces with consistent service, environment, version, and region metadata. I would create slow monitors for user journeys, dependency dashboards, synthetic checks, and drill down links from alerts to traces and logs. Ownership metadata matters as much as telemetry, because every alert must reach someone capable of acting. Focus on golden signals, service ownership, dependency mapping, standardized instrumentation, dashboards, slow monitors, synthetic checks, cardinality control, regional views, and consistent metadata across services. Question 6. What is metric cardinality, and why is it important in Datadog? Cardinality is the number of unique time series created by metric dimensions, usually tag combinations. Tags such as service or region are useful, but request IDs, user IDs, or arbitrary URLs can create explosive growth. In Datadog, that increases storage, query cost, and operational noise. I would keep bounded dimensions on metrics, move detailed identifiers to logs or traces, review custom metrics, and use aggregation or filtering before emission. While answering, define cardinality, explain tag combinations and cost, identify dangerous dimensions, distinguish useful aggregation from unbounded values, and describe controls such as filtering, aggregation, and custom metrics review. Question 7. A service is returning intermittent 500 errors, but CPU and memory look normal. How would you debug it? Normal CPU and memory do not rule out connection pools, thread exhaustion, dependency failures, or network problems. I would segment errors by endpoint, status code, version, region, and dependency, then inspect structured logs and traces for timeout or exception patterns. I would compare healthy and failing instances and check recent configuration or deployment changes. If necessary, I would shift traffic or roll back, while preserving evidence for deeper analysis. In your answer, cover error segmentation, dependency failures, timeouts, retries, logs, traces, load balancers, deployment versions, regional patterns, saturation beyond CPU, and controlled mitigation. Question 8. How would you respond to a production incident affecting a critical customer-facing service? I would declare the incident, establish an incident commander, and quickly quantify affected users, regions, and functionality. I would assign owners for mitigation, investigation, communications, and documentation. The first goal is to restore service using a safe rollback, failover, or traffic reduction, not to prove the root cause immediately. I would provide regular updates, verify recovery through customer-facing SLIs, and conduct a blameless review with concrete prevention actions. Make sure to cover incident command, impact assessment, communication, mitigation, role assignment, timeline tracking, safe changes, escalation, recovery validation, and a blameless follow-up. Question 9. How would you calculate capacity requirements for a rapidly growing service? I would establish current request rates, payload sizes, concurrency, latency targets, and resource consumption, separating average from peak demand. Load tests would reveal the true bottleneck and scaling curve. I would forecast growth, reserve headroom for failures and bursts, and validate dependent systems such as databases and queues. Autoscaling can handle variability, but it needs sensible limits and warm-up time. I would revisit the model using production data rather than trusting static assumptions. Discuss workload modeling, peak and average traffic, resource utilization, headroom, growth forecasts, load testing, bottleneck identification, autoscaling limits, dependency capacity, and cost-aware planning. Question 10. What is toil, and how would you decide whether to automate an operational task? Toil is repetitive, manual, automatable operational work that provides little enduring value and grows with the system. I would prioritize tasks that are frequent, error-prone, interrupt-driven, or directly affect on-call capacity. Before automating, I would understand edge cases and define safe validation, rollback, and permissions. A small script may be enough initially, a service or workflow is justified later. I would measure hours saved, failures avoided, and operator satisfaction. Be sure to mention repetitive manual work, human judgment, frequency, risk, time savings, reliability gains, investment cost, guardrails, and measuring automation outcomes after rollout. Question 11. What should a high-quality blameless postmortem contain? A strong postmortem explains customer impact, detection, a precise timeline, response actions, recovery, and contributing conditions. It avoids blaming individuals because behavior usually made sense within the system's incentives and information. I would identify why safeguards failed, then create specific actions with owners, deadlines, and measurable completion criteria. The review should also capture what worked, share lessons broadly, and verify that fixes actually reduce recurrence rather than merely closing tickets. Focus on impact, timeline, detection, contributing factors, decisions, recovery, customer communication, systemic causes, prioritized corrective actions, owners, deadlines, and verification of completed work. Question 12. How would you design a reliable service across multiple availability zones or regions? I would begin by defining the failure model and recovery objectives. Stateless application instances can run across zones behind health-aware routing, while stateful data needs replication, a clear consistency model, and tested failover. I would avoid sending traffic to unhealthy dependencies, preserve capacity for a zone loss, and design graceful degradation for non-critical features. Multi-region deployment adds latency and split brain risks, so I would test failover regularly instead of treating redundancy as proof of resilience. In your answer, cover failure domains, statelessness, replication, quorum, consistency, traffic routing, health checks, data recovery, graceful degradation, dependency locality, and disaster recovery testing. Question 13. How would you make a deployment safe for a critical production service? I would make deployments reversible and progressive. Automated tests and compatibility checks run first, followed by a small canary population monitored for errors, latency, saturation, and business impact. Feature flags let us separate code deployment from user exposure. I would define rollback thresholds before deployment, ensure database changes support both old and new versions, and automate rollback where possible. The safest process combines small changes, strong observability, and clear ownership. Discuss automated testing, progressive delivery, canaries, feature flags, health metrics, rollback criteria, schema compatibility, change ownership, auditability, and separating deployment from feature activation. Question 14. How would you handle a dependency that is timing out and causing cascading failures? I would first bound request timeouts so resources cannot wait indefinitely. Retries should be limited, use exponential backoff with jitter, and apply only to safe operations, otherwise they amplify overload. Circuit breakers can stop calls to an unhealthy dependency, while bulkheads isolate connection pools and worker capacity. I would provide a degraded response when possible and monitor dependency latency, timeout rates, and retry volume. Recovery requires fixing the dependency, not simply increasing timeouts. While answering, cover bounded timeouts, retry budgets, exponential backoff, jitter, circuit breakers, bulkheads, fallback behavior, concurrency limits, dependency monitoring, and avoiding synchronized retry storms. Question 15. How would you use infrastructure as code to improve reliability? Infrastructure as code makes operational changes reviewable, repeatable, and recoverable. I would store declarative definitions in version control, require peer review, run formatting and policy validation in C, and detect drift regularly. Modules should provide safe defaults while allowing controlled variation. Secrets belong in a dedicated secret manager, not source files. I would promote changes through environments, limit blast radius, and retain state backups so a failed change can be recovered. Be sure to mention version control, review, repeatability, drift detection, immutable changes, validation, secrets handling, blast radius control, rollback, and safe environment promotion. Question 16. What makes an effective SRE on-call rotation? An effective rotation has enough trained engineers, predictable schedules, backup coverage, and an explicit escalation path. Services need current runbooks, ownership metadata, dashboards, and tested recovery procedures before joining the rotation. Alerts should be actionable and limited to urgent work, otherwise the schedule becomes unsustainable. I would review pages per shift, after-hours load, response time, and repeat incidents, then invest in automation or redesign when the burden remains high. Discuss sustainable staffing, escalation paths, service ownership, runbooks, alert quality, handoffs, backup coverage, operational readiness, compensation, and reviewing on-call health metrics. Question 17. A database is the bottleneck for a growing application. What reliability improvements would you consider? I would identify whether the bottleneck is CPU, I/O, locks, connections, or inefficient queries before changing architecture. Query plans, indexes, caching, and connection pool limits often provide immediate gains. Read replicas can separate read traffic, while partitioning or sharding addresses scale but adds operational complexity. I would maintain tested backups and failover procedures, monitor database latency and saturation, and explicitly document consistency trade-offs. Premature sharding can make reliability worse. In your answer, cover query analysis, indexing, connection pools, caching, read replicas, partitioning, workload isolation, backups, failover, consistency trade-offs, and measuring database-specific SLIs. Question 18. How would you design reliable processing for messages placed on a queue? I would assume at least once delivery and make consumers idempotent using durable deduplication keys or transactional state changes. Messages need bounded processing time, controlled retries with backoff, and a dead letter queue for poison messages. Consumer concurrency should follow downstream capacity, with backpressure preventing overload. I would monitor queue depth, oldest message age, processing latency, retry counts, and dead letters. Exactly once behavior is expensive, so I would choose semantics based on business impact. Make sure to cover delivery semantics, idempotency, visibility timeouts, retries, dead letter queues, ordering, backpressure, consumer scaling, poison messages, and end-to-end lag monitoring. Question 19. How would you use chaos engineering to improve service resilience? Chaos engineering tests whether a system behaves as expected during realistic failures. I would state a hypothesis, such as maintaining an SLO during one instance loss, define steady-state metrics, and inject a controlled fault in a limited environment. Abort conditions, monitoring, and rollback are mandatory. I would start with staging or a small production slice, involve service owners, and turn discovered weaknesses into tracked reliability work. Chaos is experimentation, not random disruption. Focus on hypotheses, steady-state metrics, controlled experiments, failure injection, blast radius limits, abort conditions, observability, learning goals, and converting findings into engineering improvements. Question 20. How would you improve observability for a service using Datadog? I would install and secure the Datadog agent where appropriate, enable infrastructure and service integrations, and instrument application metrics, logs, and APM traces. Standard tags such as service, environment, version, and region make navigation and correlation practical. I would define user-focused SLOs, create monitors with runbooks, and build dashboards that support both overview and drill down. I would control custom metric cardinality and retention, because useful observability must remain affordable and actionable. Be sure to mention the Datadog agent, integrations, custom metrics, tags, logs, APM traces, service ownership, dashboards, monitors, SLOs, cardinality, and cost-conscious instrumentation. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.